Thank you so much. Look, put up. Hitesh, one last. Right, chalo. Right, ಹೋಗ್ತೇನೆ ಇನ್ನು ಹೋಗ್ತೇನೋ ಯಾಕೋ ಮತ್ತೆ ಹೋಗ್ಲು ಬೇಡ ಅಂತಿದೆಯಲ್ಲ. Yesterday, whoever has attended the meeting, that syllabus meeting, they have to, ಏನಿಲ್ಲ ಕೃಷ್ಣ ರೈಟ್ ಹಾಂ ಲ್ಯಾಬ್ ಇತ್ತಾ ವೆರಿ ಗುಡ್ what we discussed is the set bit thing, right? And set bit or a clear bit, all that bit wherever it is all direct addressing mode. It's all direct addressing mode, right? So that is about your Boolean instructions. Yeah, one more thing. You can also write it as like this. Second thing. If it is a bit addressable register, you can write P02. A is also bit addressable, right? A register. You can write A.2. Second bit in the accumulator will get set. Okay? Set bit C0. C0. Correct. No. Set bit C is there. C0, what is the meaning? 0C0 is a register? That like you have to see the FFR register. C0 is not there, I believe. It's not there. Not there at all. You cannot use 0C0. It has no meaning. I think it will throw error. Okay? Right. Coming back, what we have to discuss is data transfer is over. Logical instructions are done. Arithmetic instructions are done. Next we have to Boolean instructions are done. 4 types we have to finish. Data transfer, arithmetic, logical, branching instructions. Branch instructions. And then we have subroutines. Next we have subroutines. Some of the textbooks combine this branch and subroutine in the single heading. They call it as a branch instruction. In this they divide the normal branch instruction and the subroutine instruction again. Right, in some textbooks. But today what we do is, we'll discuss this separately. Okay? Right, under branch instruction we have 2 categories. And conditional branch. Unconditional branch and conditional branch. Okay. So under unconditional branch, what is that you have? You have S-jump, L-jump, and A-jump. 3 types, 3 main instructions. L-jump, S-jump, A-jump. And there is also simple jump, JMP. Right? Do you know what is the difference between these 3? Do you know what is the difference between the S-jump, L-jump and A-jump? Right, first thing. Why we need jump instructions? Every program executes in sequence. That is one step after that. Like it just goes on sequentially. How it goes on sequentially? Because your PC, program counter, which points to the next executable instruction, by itself increments to 1. It's a default process. So it is sequential. One after another, it keeps on going to the next location. Now you have got an option where in which you have come to a decision instruction, where in which that instruction is true, you go here. If that instruction is false, you go here. So you have two options now. In such a case, you require a program branching instruction. These are called as program branching branch instruction. Program branching because you can see it here, right? That what is the meaning of this? In sequence, whatever the PC was going on, suddenly it goes to some location here or some location here, right? How do we do this? Using program branch instruction. In that there are two types. One is in the unconditional, there is sjump, jump, sjump, right? Now when I say sjump, then like some label, this label, what is the size of this label? This is short jump, this is long jump, this is absolute jump. Three types are there: short jump, long jump and absolute jump. We'll discuss with short jump now. When I say short jump, the label size is 1 byte. 1 byte. What happens is exactly PC equal to whatever the PC value now, that is equal to PC plus label. So this label will give the relative addressing for the PC. It will not change the complete PC value. For example, PC is now 1000. The label is FF. Now it will become 1000 FF. Only last two digits are changed. Last two digits changed. Is it clear? This is short jump. Short jump happens with 1 byte. What is the size? With 1 byte, the size is 0 to 256 only, or 0 to FF only. The address, maximum change in the address can be 002 FF. In this again we have signed operation. That is, it can jump forward and it can jump backward. So you have the range from plus 128 to minus 127. Backward 127 address, forward 128 address. If your, we'll give an example and then understand it particularly. So in here it is called as a relative addressing. This has become relative address now. Whatever the PC value is a base address. In this case we have taken 1000 as an example. 1000 is a base address. This is a relative address to that 1000. Is it clear? Right? Done. We'll take one small example for this. What is the example? We'll say INC A, increment A, and sjump here, and then end it. This is all my program, such a small program. I am just incrementing A, whatever the A value, sjump here, here is here only. Here is here only. This is infinite loop and then end. Okay? If I check the ROM address now for all this, what is sjump opcode? Opcode for sjump. Increment A first, you tell me that. 4. Okay, next sjump. Sjump here 8. 80. Right? Then n does not have an opcode, but like this sjump has 80. What about here? What is the value of here? Sjump is 80. Sjump here, this address keeps on changing. So what we do is we'll write here only. What is the address? We will fix it later. Okay. Now if I consider this in your normal program, we'll include one more instruction. Move a comma hash 20h. What is this? Opcode for this? Move A opcode in 74, right? Move A is 74. That is 74 and then 20. Correct? 74 and 20. So I can write it as 7420. In this 74 is the instruction, 20 is the data. Right? In this 80 I can write here itself. In this 80 is instruction, here is the address. Okay. Now if I give the PC value to this ROM value, ROM address. Let's say it starts from ORG 40H. We have written program from 40H. So this is 40, this is 41, this is 40, this is 41, this is 42, this is 43, this is 44, here is 44. Then like end, after this it will go become, sorry, what is that? 44, 45. It will become 45. After that, like it goes on, from 40 it starts, 45, 46, it goes on, the memory locations in the RAM. Our program end at 45. Okay. Now what happens? This is an opcode. This we discussed like this. RAM address, opcode and the assembly code. No? We have discussed. This is ROM address. Yeah. Now what happens? When your program starts, when you start your program, as it says ORG 040H, PC will become 0040H. PC will become 0040H. ಯಾಕೋ ಹೊಟ್ಟೆ ಅಷ್ಟಿದೆ ಬೇಜಾರಾಯ್ತಾ? ಬೆಳಗ್ಗೆ ಅಂತ ನಿಂದೆ ಕೇಳಿ ಬೇಜಾರಾಗ್ತದೆ ಸರ್ ಅಂತ. ಯಾ right. Program starts with 40H, right? In 40H, this instruction is there, it will execute. You know what it executes. A will get 20 in this. Next instruction is 42. Next instruction is 42, not the 41. 41 has a data. So PC goes to 42 and does this instruction execution. So 20, A is 20, now it becomes 21. Next instruction is at 43. It executes that with 44 as an address. So value for this is 44. Right? Now it comes to the 45. If this is done, this is executed in the sense that it will not cross this instruction anyway. But when it is executing this, it will point to the 45. You have to understand that part. Is it clear? When it is executing yes jump, controller is executing yes jump, PC is pointing to the end 45. Because PC will always point to the next executable instruction. It thinks that next executable instruction is at 45. It goes there, right? But what your yes jump says is like jump back here, so it will come back here. So now the address for here is not 44. 44 is a RAM address. What is the value for this here? It has gone to 45. Right? Now, when I say like yes jump here itself, yes jump here and it is jumping back here, the controller PC has to be made as 43. Right? That is where the value of here is FE. 2's complement of the 2. You are understanding? This is a trick. This is a logic that you have to think on. See now, PC is pointing to 45. You understood this first? Whenever a certain instruction is executing, for example, INC is executing, that means PC will be fetching the next executable instruction, thinking that it is in sequence, right? After the execution of this, the address is decided. Okay? So, when it is executing sjump, the PC value is 45. PC executing. Then once it executes this, then it understands that it has to jump here itself, 43. So, 0045 minus 43 is a value that you have to load it in the here. Right? As it is backward, 45, it has to come back. It is minus 2. That is 02 minus 02 is 43. PC equal to 43. The PC address has to be 43. The meaning, what I am saying is, PC address has to be 43. Once it is pointing it here, it has to come back here and again execute this instruction. Is it clear? Is it clear? Now what I am doing, 45 minus 2, 45 minus 2 I have to do, or like 45, there is no minus 2, nothing called minus in 8051, it is all plus only. So plus FE, 2's complement of minus 2. 2's complement of minus 2. It is like this, 45 plus of minus 2. Is it clear? Is this clear? That is where it is 8FE. Why this FE is there? This is the reason. You understood this? Did you understand this? ಏನು ಇದು ಓಕೆನಾ ಅಲ್ಲಿ ಹೋಗು ಅವನ ಹೋಗು guys, is it clear? Is it clear? If there are some more instruction here, for example, if I push it here, sjump here is here, now here, then okay, then this will be the good example. And what will be the value here? Now it is here 45. 45 has to be made to go to 40. 40. 40 it has to be minus 5. Minus 5. What is the value for minus 5? You have to put that there. You have to FE, FD as a C, then FB, next FA. So it has to be FA. 5 minus agಬೇಕು 5 this has to be. Correct, right? FB. ಇಲ್ಲ ಅಂದ್ರೆ ಇದು ಮಾಡ್ರಪ್ಪ 00000101 5. Then like takes one complement of this. No, B, FB. Whose complement you do it, you will understand. It is FB. Okay. So it has to be FB in that case. Please write down this example and mark it as this and explain why it is FB. FB represents minus 5. Why it is minus 5? Because it is pointing, PC has gone to the next instruction. How? Assembler does that. Assembler, your controller will not understand here. Here is given to the assembler. Assembler will calculate this address. How it will calculate? Based on the instruction given by sjump. Now according to this, it is there, this one. 45 this one, and then it will understand FP. Assembler does it. This is opcode. This is an assembly code to opcode conversion is all done by assembler only. Keel software is what it does. This. Any doubt? Ninge artha idena? Very good. ಮತ್ತೆ ಹೆಸರೇನಿದಲ್ಲ ನಮ್ಮ ಇವ ಹುಡುಗ ನೆಕ್ಸ್ಟ್ ಹರ್ಷಿತ್ ಪಕ್ಕ ಇದನ್ನಲ್ಲ ಏನೋ ಇದ್ರಲ್ಲಿ ನಿನ್ನ ಹೆಸರೇನಿದಲ್ಲ ಫರಾಜ್ ಅರ್ಥ ಆಯ್ತಪ್ಪ Right. Any doubt in this? Please mark FB equal to -5 and explain why it is -5. Why it is -5. And you can also mention, as Nicholas said, this is done by an assembler. This address calculation is done by an assembler. When we were a student, we used to calculate it and type it. Right? That was really a very good experience. Now you don't understand anything. Right? Okay. Shall we go to LJump? LJump with this. Next, LJump. Is very simple. Directly PC equal to label. There is nothing like this calculation and all. Okay. We'll see like LJump here. LJump label. In this case, the label is 2 bytes. 2 bytes. When it is 2 bytes, it is from 00000 to FFFF. Oh, there is one more point. Listen. If this program is too lengthy, let's imagine there are a lot of instruction here before sjump, and between move and sjump, there are a lot of instruction. The instruction has increased so much that like this address calculation goes beyond FF. Goes beyond FF. Then your assembler will throw an error that like sjump cannot reach the targeted address. Sjump cannot reach the targeted address because it can handle only 00 to FF. Distance from this memory location, ROM memory distance. Maximum change has to be FF. Maximum change. If it is beyond that, it will not take it. Sjump will not work. Is it clear? Is that clear? When I say that one again, like it is like this. Basic address is 45 now. 45 now. You should not have the targeted address as 0134. It will not work. Will this work? Acha. 0F34. 100% it will not work. You are understanding? Target address should not, PC value should not become this because it is not possible. Okay? Done? Right. So that is why it is called a short jump. Short jump, the range it can jump is 127 addresses front, 128 addresses at the back. Okay? Right. LJump. LJump is what? LJump, what it does is PC equal to a label. It directly puts the PC value, replaces the PC value to the label. Previously it was PC plus label. Now it is PC itself will become label or label will become PC. What is the advantage? It has access for 64 kilobytes of memory. Leave off your 4 kilobytes in the internal ROM. Maximum is that. External RAM ROM, you have also like LJump can go anywhere in the ROM. Or anywhere in the RAM. 64 kilobytes of external memory. RAM or ROM? We'll see why it is both. 99% it is RAM only. 1% it might also jump in the ROM. Oh, sorry. 99% it is in ROM only because all jump happens in the code memory. This it is also in the RAM memory. We'll take that example. Is it clear? Right? This is very simple. Anywhere in the RAM or ROM, it is accessible. Label, LJump. That is why it is called as long jump. Then there is one more guy. AJump. AJump. This we don't require, right? That is why sjump is also called as relative addressing mode. Sjump is an instruction under relative addressing mode. It is not only in the direct addressing mode, indirect addressing mode. Sjump comes under relative addressing mode because FE is a value which is related to the PC which existing now. You are understanding this? FE is a value for the sjump because it is existing value of PC. So it is relative addressing mode. Address is related to the existing address. That is why it is relative addressing mode. It comes under relative addressing mode. Right. Yeah, A jump. In A jump, the label is 11 bits. 11 bits. Label is 11 bits. And this also is the same as the relative addressing mode. PC equal to PC plus label. PC plus label. This is 16 bits are there. In that 11 bits are affected by label. Right? Same thing. The 11 bits in the sense 2 raised to 11 is 2 kilobytes. So with yes jump you can access 2 kilobytes of memory only. That is what your kill program restricts you to do it. Ask you, it is a evaluation code restricted for 2 kilobytes. Right? In that 2 kilobytes you can use A jump and jump anywhere. Okay? Right? Done? Right. So these three are like unconditional. There is no condition. When it is just jump, it will jump. What is conditional instruction? Conditional jump? Conditional jump is jump on carry. That depends on the memory size. Long jump, if I say L jump for this there is 1 byte of code. The address is 2 bytes. 2 plus 1, 3 bytes. If it is short jump, it is 2 bytes. It depends on that. If you can save the memory in that also, let's save it. Okay? Right. What conditional instructions or conditional branching? Jump on carry, jump on no carry, jump on bit, jump on no bit. Then jump on 0, jump on no 0. What else is there? DJ and Z. Then you have CJ and E. No, only this, in this what we have. JBC, what we discussed in the JBC. Not carry. It is jump on bit. If that bit is set, you jump and clear that bit. We missed out this, right? We'll discuss that and then we'll go to this. JMP is at A plus DPTR. There is one special instruction. JMP A plus DPTR. Instruction sheet, please check this. Please check this instruction. Is it correct? Right? This is the instruction. This is one special instruction is there. JMP at A plus DPTR. So wherever you want to jump in RAM, you have to use this. All the rest of the jumps are in ROM. Wherever your code is sitting, right? In your code you are doing branching. In here it is, you want to, this is useful to access the arrays A of 13, right? 13th in array 13 value you want to access. How do you do that? Base address you give here, 13 you give to this, it will directly value will come. In the RAM, because all variables are stored in the RAM. Is it clear? Please write down this instruction clearly. There is only one instruction available with this. Correct, right? Is there any other instruction, JMP? There is only one instruction available like this. No, LJMP, no, this is only instruction for RAM. This conditional instruction. No. Did I say like that? Then like see, all jumps L jump, short jump, A jump, they by default refers to the ROM. Branching, when I say PC value changes, it is only for ROM. PC is, I said in the perspective that like all the jumps or branching will happen in the only ROM, 1% of some branching will happen also in the RAM, like that. With respect to this total, I said like that. If that is a point that I have made, like please clarify that point, or please correct that point as like this. Is it clear? Please write this instruction and also write an example as A13. You will understand it with respect to this. Done? Let's go to quickly the other conditional jumps. This is all in the conditional jumps. CJ, NE, DJ, and Z, JB, JBC, JBC I have written, and JC, JNB, jump on no bit, jump on carry, done, then that's all. So how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 branch instructions. What was the number? 27 plus 13, 40. So 4 subroutine instructions are there. What is reserved? What we have not discussed is an op. One opcode is reserved, A5. A5 opcode is reserved. Mnemonic, like it is they have to give and we have to study only that. There is totally 30 instructions we have studied if we finish this. Let's quickly look at this. Jump on carry, you know. We have discussed and we have studied on this with respect to search an element. Search an element. Jump on no carry and jump on carry are like largest number or smallest number. Bubble sorting, ascending order and descending order. These are the instructions. Then jump on bit and jump on no bit. This is used if there is a particular bit is set in the bit addressable memory. Jump on bit JB A, 3 or A dot 3. Accumulator third bit is set. Then you jump. This is the meaning. JB, this, where, label. It has to be labeled. Check maಡು, format check maಡು. JB, but where? No, I am saying like instruction format. Correct. This is only. JB A.3 label. This is the instruction format. How instruction should be written. The JB is the instruction. Which bit it is checking? Accumulator third bit. Where it has to jump? Here. Is it clear? Right. Oh, one more important point. By the default, all these conditional jumps are yes jumps. They are only short jumps. They are not long jumps or absolute jumps. Got my point? Mention that is very important. Or like you can also mark that arrow. By default, all S jumps. Range for JMP. It is also short jump. It changes only with respect to A. DPTR from 00 to FF. So it is again a short jump. Any conditional instruction, they are all short jumps. All are short jumps. Okay. So this you know. Jump on 0. Janavi. Vandana. What is jump on 0? What it does? It does smiling. Anybody? Food poison, madam. Tell me. Quickly. What is 0? Which bit? Carry bit. That is jump on carry. When accumulator is 0, jump on 0 by default refers to accumulator. Please mention it here. Jump on 0, jump on 0 by default refers to accumulator. If A contains 0, then it jumps. Jump on 0. Okay? This is very important. By default it refers to accumulator. Only accumulator. You cannot give any other register at all. Not possible. Jump on 0 label. It is jump Z label. JZ label. Like this, we are jump on bit, we are checking the bit. Where we are checking the 0. By default it refers to accumulator. Clear? This you understood. That is the example. This you know. Carry flag in the PSW. What about DJNZ you know? DJNZ you are all familiar now. DJNZ R3 comma label. DJNZ R3 comma label. One register RN. You can make it as RN. Any register. DJNZ takes any register. Or DJNZ has two types. DJNZ has two types. One is register addressing mode, another is direct addressing mode. You can also give the direct addressing here. DJNZ, you write two examples here. Example one is this. One is this DJNZ RN comma label. The other is DJNZ 40H comma label. 40H comma label. DJNZ 40H comma label. 40H refers to the general memory location 40. In that, whatever the number is there, decrement that number. If that becomes 0, then like jump to the label. Non-zero.